Hey guys, how are you? Welcome back to the channel. Today is day 17 of upskilling myself, and today was a very productive day. I would say the most productive day in this past 16 17 days. And today I solved 4 DSA problems. So let's see the DSA problems that I solved. So the first problem was ransom note. It's an easy little problem. So we have been given two strings, let's say A, B, which is the magazine, and the second string is AA, which is the ransom note. So we have to form this ransom note using the characters of the magazine. So the approach that I used was I set a counter array to store the frequency of all the characters. So if the character is B, we minus character A from it and we get 1, right? So we increment the count of the first index into the array. Then we do the same for the magazine and then for the ransom node. And when we remove the characters from the counter from the ransom node string, and if we get 0 or less than that, we return false because we don't have the characters to fulfill the ransom node, and if else, we return true. So it's a pretty easy level problem. Code and decode the tiny URL. So it was not related to any algorithm as such, but it was more of related to system design and yeah, just for the logic purpose. So yeah, we define base URL character set, the character set to generate a key, then we get a random key, and then we encode the URL into a shortened URL. Okay. So if we find the uh, long URL in the hash map itself, then we return the shortened URL, and else we create a random key and store it in the hash map where the long URL is associated with the key and the key is associated with the long URL. Then we return the base URL plus key, and then we decode the shortened URL into its original URL, and this is the function for it. We get the string key substring of the short URL. So if the short URL is something something.com slash this part over here, so till this part, this is the base URL. We don't consider this part and we consider this as our key. Okay, and then we return the mapping of that particular key in short to long. So short to long, we assign key and value is the long URL, right? So we got the key, and from the key we can get the long URL. So the next problem was maximum sum of distinct subarrays with length k. So we have to find elements or subarrays whose length is 3 and whose output is the maximum, right? So what we do is we use sliding window for it, because in the earlier video I told you that if we are given a fixed window size, then we use sliding window. So we create an unordered map to store the element and its frequency. Then we traverse the array, and then we store the element into the hash map and increment its frequency. Then we add that element into the sum, and if the window is greater than k, then we remove the leftmost element and I add the rightmost element into the window and also modify the sum. And then if it's removed from the hash map, then we erase its record from the hash map, right? So if the window is of size k and all the elements are different, then we consider it for the maximum, right? And then we return the maximum. So the last question was trapping rainwater. So it was a hard little problem and it was a pretty good problem. So to solve it, we used two pointers, one pointer on the left, one pointer on the right. So we have to find how much water is stored in these gaps. So let's take an example. If you have been given an array like this, okay. So if you see, if the water can be stored till the shorter side, right? So the maximum that we can store the water is the shorter side, right? So this is a point to keep a note of. And then the water stored for every index is the size of it minus the element size. Okay, so this is the remaining water that is stored, and then we add it into our answer. Okay, so first of all, we get the left max and the right max. Then we use two pointers to traverse. The left max is smaller. Then we calculate according to it and do the pointer is incremented. Else, this pointer is considered and this is decremented every iteration. Okay, so yeah, this is the basic initialization. Then while L is less than R, we get the left max and the right max. Then we calculate according to the minimum side. Then if the left max is less than the right max, then we add the left max minus height into the answer and then increment L. Else we add the right max minus height into the answer and decrement the right pointer and then return the answer. Then for the development part, I did my internship work, then revised AWS basics, then revised some tricky topics of JavaScript, then worked on my personal project, did YouTube stuff, and revised all the questions that I solved in DSA till now. And yeah, that was it for today. Thank you guys for watching and see you on day 18.